Hi there and welcome to another video from HEGARTYMATHS, another GCSE revision video. In this video we're still solving linear equations, however we're solving those equations as they arise within the geometry style questions of AQA Unit 3. However, this applies to most GCSE maths modules or linear courses. For more help with your math studies, do check out the YouTube channel or follow me on Twitter at HEGARTYMATHS. Now, this video might be reasonably long. I'm going to go through some of the basic geometric principles you need to know for the GCSE higher paper, and then I'm going to introduce you to how they come up with regards to linear equations. Okay, so we're going to do quite a few examples here. Take down some notes, try and do the examples, and watch out for all the exam tips I'm going to go through with you. Right, to start with, some of the things we need to know, the geometric principles. This picture here is telling me, is a rule I need to know, and it's that angles on a straight line sum to 180 degrees or add to 180 degrees. So we just need to know that. This angle is telling us that opposite angles are equal. Again, another thing we must know. So this one and this one are equal, and these two are equal because they're opposite. A principle we need to know. Okay, what else do we need to know? What other big ideas do we need? Well, this picture here is supposed to say that angles in a triangle sum to 180 degrees. Again, you should know that, fairly straightforward. And here, this one is that angles in a quadrilateral, quad meaning four, so a four-sided shape, sum to 360 degrees. Again, you should know that. Extending this to any shape, I've just drawn ourselves here a 1, 2, 3, 4, 5, 6-sided shape. And so I wonder what all the interior angles, the angles inside are called interior. Okay, this is non-regular, this shape. What do all these blue angles add to? Well, the way I would usually work something like that out, probably the simplest way, pick a corner, any corner, and then draw straight lines from that corner to the other corners, as follows. Okay, now inside each, we have now created four triangles where the angles are as follows. Okay, so we have four triangles, 1, 2, 3, 4. Okay, inside each triangle, the interiors of a triangle are 180, so we've got four 180s, and 4 times 180 is 720, and that's the sum of all the inside angles. And you could do that with an n-sided shape. Here we had a 6-sided shape, and we did 4 times 180. If you had an n-sided shape, say 10 sides, well, this number is always 2 less than the number of sides, so you would have n take away 2 times 180 would tell you how many triangles there are, and multiplying by 180 tells you the sum of all the interior angles. You should be able to do that. Now, with a regular shape, assume here we've got a regular shape, i.e. all the sides are the same length and all the angles all the interior angles are the same length. So if I label this interior. Now I've highlighted on this picture the exterior angles. These are the exterior angles, and they're the angles that the shape makes if you extend one of its sides as a straight side. If you extend that, the angle that extension makes with another, with the next side along. So this picture is trying to show me that you always know that the exterior angles of a polygon, exterior angles of a polygon sum to 360 degrees. Okay, and the reason you might be able to see that, if I took this shape here and I condensed it and condensed it and condensed it, can you see it makes a point and angles around a point at 360? Hence, all those angles add to 360. Now, if they're all the same, I have one of them, two of them, three of them, four of them, five of them in this case. So if each one's x, we have 5x is 360. 1x would be 360 divided by 5, which would be equal to 72 degrees. So if this is 72 degrees, I get this one for free because they're on a straight line. This must be 108 degrees. Okay, so the big idea here is the exterior angles of a polygon sum to 360. Then we have to know some rules about parallel lines. These are notifications that these two lines are parallel and these two angles are the same. And the rule is that alternate angles are equal. Also, these two are the same, and these are corresponding angles are equal. And these two, they're not the same, but they add to 180, and they're called interior angles. So interior angles add to 180. Again, 3 facts you need to know. Okay, and the last big facts you probably need to know are the circle theorems, which, I've done videos on this on my YouTube channel, so do check those out for more depth. But quickly running through those, imagine here's the center of each circle. Let's just label those in. I'm going to give you probably a 3-minute tour of the circle theorems. The first one, this isn't really a theorem, but it's just something you should be aware of. If you see a triangle in a circle where 2 of the sides are a radius, you know this is an isosceles triangle. Okay, so for example, if you were told that this angle here was something like 70 and this was, then you could work out the other two because they must, these two are the same. Okay, so that's not really a circle theorem, but something you should be familiar with. Okay, probably the first circle theorem is as follows. Oh. And angles, these angles are facing the same way. And this is angle at center, double angle at edge. So angle at center, double angle at circumference even. Okay, extending this, imagine I extended this point here. So this was a straight line. Can you imagine that this angle at center would now be 180? And therefore, if this is half it must be 90. So the other rule is an extension of this rule. It just says as follows. It says angles in a semicircle containing 90. That must be 90 degrees. Because this is 180 and that's half it. So angles in semicircle contain 90. Okay, next, if you define yourself a particular arc length, let's say that, okay, if you draw 2 lines to a circumference from the same arc length, then this angle and this angle are equal. Similarly, looking at it the other way around, if this was your arc length and you drew that triangle and that triangle from it, these two must be equal. Okay, so angles from the same segment are equal. Angles from same segment are equal. I won't write that one down. The next one, probably the biggest one in these type of questions, are circles that look like this. This is a circle with a quadrilateral inside it. This is called a cyclic quadrilateral because all 4 corners lie on the circumference of a circle. And we're supposed to know that the opposite angles add to 180. So opposite angles in a cyclic quadrilateral add to 180. Next one we should know, when a tangent to a circle, a line that just touches a circle, meets a radius, they meet at 90 degrees, as follows. Next one we should know is the alternate segment theorem. If you've got a tangent to a circle and it meets a chord, so the tangent's meeting the chord here, this entire angle is always equal to the opposite angle in the shape formed, and similarly this angle here would equal this angle here. So this is called the alternate segment theorem. And the last one, if you take any point in space and you draw two tangents to it, two tangents from that point to the circle, okay, then this length and this length must be equal to each other. Okay, I haven't written all the details in there, but I've done a very substantial circle theorem video previously, which you can look up in the AQA video section. However, that's enough for now. Let's answer some standard questions. Okay, example 1, find the smallest angle. Whatever you do here, please set up your algebra perfectly to get all your method marks. So, angles in a straight line add to 180. Therefore, 2x plus 3x plus 4x are equal to 180. That gets you a mark for method working marks. Combine x's. We have therefore 9x is equal to 180. Tell the examiner what you're doing, divide by 9, x is therefore 20 degrees. Now, if you just wrote that, you'd probably get 3 out of 4 marks. It asks for the smallest angle. Well, therefore, always go back in and fill these in. 2 times 20 would be 40. 3 times 20 would be 60. And 4 times 20 would be 80. Do these add up to 180? They do, so I know I've done it right. Therefore, the smallest angle to get your final 4th mark would be 40 degrees. Okay, so nice and straightforward. Example 2, find each angle here. We're using the same rule, other than the algebra is slightly more complicated. These must add to 180. So let's write down our first mark for our working mark. 2x plus x plus 10 plus x subtract 30 must add up to 180. Okay, 1 mark for that. Next, count your x's. 2x plus another x is 4x. Count your numbers. There's nothing here. We've got 10, add negative 30. That's like 10, subtract 30, which is negative 20, or subtract 20, equal 180. Let's add 20 to both sides. For tidying up there, you get another mark. Adding 20, we get 4x is equal to 200. Dividing by the 4, we will get x is therefore equal to 50. It says find each angle. So we found our x here, that will get us the 3rd mark. To find each angle, we substitute back in. 2x would therefore be 100 degrees. Okay, x plus 10 would therefore be 60 degrees, and x subtract 30 would therefore be 20 degrees. Do they add up to 180? They do. I've done it right. So the angles, label the angles, are 100 degrees, 60 degrees, and 20 degrees. The picture doesn't look very accurate, however, the algebra's worked out like that. So make sure you read the question. Next, example 3, find each angle. Well, angles in a triangle add to 180. So let's get our method mark. 5x plus 9x plus 4x must be equal to 180. If I add these up, I get 18x is equal to 180. Dividing by 18, I get x is equal to 10 degrees. That's not it. It asks us to find each angle. Therefore, the angles are 50 degrees, 90 degrees, and 40 degrees. Check they add to 180. That gives you some comfort you've done it right. And there you go. Example 4. Angles A and B in a quadrilateral are in a ratio 2 to 3. Angle C is 30 more than angle B. Angle D is a right angle. Find each angle in the quadrilateral. Let's draw a quick picture to represent this. So angle D is a right angle. So let's just draw angle D here, like that. Label that D. And then we're told that A and B are in the ratio 2 to 3. So let's just draw it something like that. It doesn't have to be accurate. Imagine this is angle A, B, C, D, let's just say for argument's sake. Now, angles A and B are in the ratio 2 to 3. So if we say that this is equal to 2x, this angle here must be 3x, okay, using the ratio argument. So introduce algebra. Angle C is 30 more than angle B, so angle C must be 3x plus 30, and angle D is 90. Angles in a quadrilateral add to 360. So let's write our algebra down. 2x plus 3x plus 3x plus 30 plus 90 adds to 360 degrees. Let's combine x's. 2x plus 3x plus 3x is equal to 8x. 30 and 90 is 120. Subtract 120 off both sides. Divide by 8. X is therefore equal to 30. It says find all the angles. Well, this is 90 degrees. 2 times 30 is 60 degrees. 3 times 30 again is 90 degrees. And 90 degrees plus 30 is 120 degrees. So state the angles. They're 60 degrees, 90 degrees, 120 degrees, and 90 degrees. Do they add up to 360? Well, these two are 150, plus this one must be 270, it's 360. Yeah, they do. Example 5. The perimeter of the following triangle is 37 centimetres. Find the sides. So, the perimeter is the distance around the outside. So we can say that 4x here, plus x plus 7 here, plus 3x subtract 2 must be 37. That gets you 1 mark. Let's combine x's. That'll get you the second mark. 4 plus 1 plus 3 is equal to 8x. Let's combine the numbers. 7 subtract 2 is 5. So that will get you this another mark is equal to 37. Then subtract 5 off both sides. 8x is equal to 32. And divide by 8. X therefore must be equal to 4. 4. Okay, and now find the sides. Well, the sides, 4 times 4 must be 16 centimetres. 4 plus 7 is 11 centimetres. And 3 times 4 is 12. Take away 2 is 10 centimetres. Do they add to 37? Indeed they do. I've done it correctly. So state your sides are 10 centimetres, 11 centimetres, and 16 centimetres. Okay, continuing. Example 6. It's getting slightly trickier now. It says that the diagram shows parts of 2 regular polygons A and B. A has 12 sides and exterior angle 2x. B has exterior angle 3x. Work out the number of sides of B. Now, here's the rule you should know, that the exteriors add to 360. Okay, and in this case, with A, we've got 12 sides, so 12 exteriors, and each of them are 2x. So 12 lots of 2x must add up to 360 degrees. That's 24x is equal to 360 degrees. Divide by 24. So we would have 36 divided by 24. 360 divided by 24 is 15. X is equal to 15, therefore. So, work out the number of sides of B. Now that we know x is 15, this angle here must be 45 degrees. And all of the angles must add up to 360. So if we do 360 divided by 45, it tells me how many of these we must have, and hence how many sides. So 360 divided by 45 is 8. So therefore we have 8 sides. And we're done. Example 7. This is quite a tricky one. It just says find x. Something like this would be about 5 or 6 marks. Now, firstly, just keep it simple and start off by noticing these are parallel lines. So we're using our alternate, corresponding and interior angle rules. Now, firstly, you should spot that this one must equal this one. Okay, so state that. y plus 20 must equal 60, and the reason they are corresponding. Write that. That will probably get you 2 marks. You can solve this equation to find y. If you subtract 20 off both sides, y must be equal to 40. So let's fill in the angles we now know. That's 60, and 2 lots of y would be 80 degrees. Right? Now, the next thing you should think to yourself is this one and this one, the whole one there, they're interior angles. They add to 180, right? So this whole angle here, 2y plus 60 must be 140, because y is 40, 2y is 80, 80 plus 60 is 140. So therefore these two, x plus 140, must add to 180 degrees, and that's because they are interior, another mark. So therefore x must be 40 degrees, your final mark. Okay, and that there would be 5 or 6 marks. It's quite complicated, but just keep it simple. Notice parallel lines, solve equations to find y, and then use that to find x. Okay, question 8. The dimensions of a cuboid are 4x plus 3, 2x plus 1, and x plus 3.5 centimetres. And here's the key line. Given that the width is 5 centimetres more than the length, find the volume. So, the length, the width here is this one, and the length is this one here, and this is the height. So, we are told the width is 5 centimetres more. So if we 4x plus 3, if we subtract the length, which is 2x plus 1, this take away this must be equal to 5, because this is 5 more than this. Tidy this up with algebra. 4x plus 3, this is take away everything in this bracket, subtract 2x, subtract 1 is equal to 5. So how many x's do we have? 4x, take away 2x is 2x, and we've got 3, take away 1, which is 2, it's equal to 5. Therefore, take away 2 off both sides, 2x is equal to 3, and x is therefore 1.5, right? So, we are asked to find the volume. So therefore, what are the dimensions here? Well, 4 times 1.5 is 6, 6 plus 3 is 9 centimetres. 2 times 1.5 is 3, 3 plus 1 is 4 centimetres. Their difference is 5, as we're told, so we know we're on the right tracks. And x plus 3.5 would be equal to 5 centimetres. So the volume is therefore 9 multiplied by 4 multiplied by 5. And if we do that, 9 multiplied by 4 multiplied by 5 is 180. And don't forget the units, centimetres cubed. And we're done. Last 2 examples now. Example 9, the diagram shows a quadrilateral ABCD. Prove that AB is parallel to DC. So we're trying to show that AB, so this should be A, B, C, D, my fault there, apologies. We're trying to prove that this is parallel to that. Now, if they were parallel, these would be interior, they'd add to 180, and so must these. But what do we know for sure? That's if they were parallel. We don't know they're parallel. We know this is a quadrilateral. Angles in a quadrilateral add to 360. So get your method mark. X plus 3x plus 2x plus 4x must add up to 360. How many x's do we have? 1 and 3 is 4, add 2 is 6, add 4 is 10x, would be 360. Divide by 10, x must be 36 degrees. Therefore, we can label these sides now, can't we? So 2 times 36 is 72 degrees. 3 times 36 is 108 degrees. 4 times 36 is 144. And this would just be 36. Now we need to show they're parallel because 72 plus 108 equal 180, they're interior. And similarly, because 36 add 144 add to 180, they're interior. And the only way this could be true that they're interior is that AB and DC are parallel. And again, that would be a 5 or 6 mark question. And the last question now, example 10, PQRS is cyclic quadrilateral. Prove that PQ is parallel to SR. PQ, this one is parallel to SR, even though it doesn't look like they are. Because it's cyclic, opposites add to 180. What opposites do we have? Well, we don't know this one, but we know these two add to 180. Let's write some algebra. 3x plus 10, okay, add 7x, subtract 30, must add to 180. How many x's do we have? 3 and 7, which is 10x. The numbers, we've got 10, take away 30 is subtract 20 is 180. Let's add 20 to both sides. 10x is equal to 200. Let's divide both sides by 10. X is therefore equal to 20 degrees. So let's fill in what we know. If x is equal to 20 degrees, let's fill this in. This angle here, 3 times 20 is 60, plus 10 is 70 degrees. This here must be 7 times 20 is 140. Take away 30 is 110 degrees. This here must be 4x plus 30. 4 times 20 is 80, plus 30 is 110 degrees. And therefore the angle at R is equal to 360, take away 110, take away 110, take away 70. Which will give me 70 degrees. So this here is also 70. Now, because P and S add to 180, they are interior. And because Q and R add to 180, they are interior. Therefore, Q and SR are parallel. And it's a bit like the last question, and we're done. And that's it for this particular video. So finally, just to say, I hope you found that useful. The next video we're going to be talking about how to solve some simple simultaneous equations and moving on to the geometry style questions of that. If you've got any other issues, do look at the YouTube channel or Twitter. So check it out for now. Catch you again sometime.